So this is the Computing Talent Initiative's, first workshop introduction. We're going to cover Python, Module 2, and also kind of how the class is going to work. So to kind of introduce the Computing Talent Initiative, you may have noticed by logging into Slack, there's a lot of different universities, a lot of different students from different universities. So this course is being taught kind of remotely across a bunch of different universities. There's a lot of different faculty. I don't personally know every single one of your teachers, but I hope to get to know them during this course. It's an industry-aligned curriculum developed in partnership with codepath.org, which is kind of where I work. Basically, we go out into industry and we look at, what are people doing in actual startups and actual companies? What are they really building? And we try to bring that back to university students so that you can, be really prepared when you actually hit like the job market, and really that you're working on stuff that people are using right now. And then, so this course is really about aligning your practice with interviews. So, the goal is really to help you get a job or help you get an internship. So that's the main point of this course. We're not going to grade you and be like, well, you got an 87 and you got a 64. That's not what we're up to. We're really just trying to help you get through all of these problems so that you kind of have like a base of things to match against. And that's because I know a lot of people at a lot of the big tech companies, and I know that every tech company does not even receive as many applications as they have open positions right now. Like, that's how bad it is. So everyone, really needs you to learn to code and be an awesome engineer. And so, everyone's kind of rooting for you, right? That's why all these initiatives exist. So yeah, to introduce myself, I'm Liz the Developer. That's where you can find me on the internet if you Google Liz the Developer. I got started coding in 2001. Me and my dad started a startup. I was a kid, and he just kind of dragged me around to a bunch of customer meetings, and then I would write code based on what they needed, and that's kind of how I learned to code. Mostly, I freelanced my way into tech, so I'm different than a lot of people kind of in the industry, and a lot of the people that you've probably met, in that, it wasn't so much about my degree or my qualifications when I got my first few jobs. It was about having some experience. That doesn't mean that you need experience, but it is one way to have an entry into, the tech sphere. What I think y'all should take away from that is that, no one's gonna judge you really too much based on some small detail about, this class or that class. They're really gonna want you to just be able to solve problems and write code. And that, you're in your university to learn to do that. So, yeah. I have done some big stuff. I wrote the fraud prevention system for 8 of the top 10 banks in the country, and that's my I've done some big stuff thing that I use to kind of break my way into Silicon Valley. Most of your debit cards are pretty much protected by an algorithm that I put into place. It's iterated since then, yeah, I put it in place. So that's cool. But when I moved to the Bay Area, I was showing up and telling everyone I did all this cool stuff, but interviews were terrible. They were terrible for me, and I had 10 years of experience at that point. And I just went through all these different interviews, and really it was about not having been exposed to the actual problems that were coming up in interviews. I knew how to code and solve problems, but I didn't know how to solve these particular problems, and I hadn't seen these patterns before. Patterns are such a big part of it, and so I just really struggled. But I made it through, and I founded a bunch of different startups and other educational programs like Hackbread Academy, Galvanize, Tradecraft, Anki.com. So I've worked with a bunch of different startups. I also worked with CJ Silvario, the CTO of the NPM framework up until recently. And so I've worked with a bunch of different startup people, I've kind of been in the startup scene for a little while. But I've also worked at a bunch of larger tech companies, so I've kind of seen the gamut, and that's what I'm aligning this curriculum to. Most recently, I was the CTO of Anki.com, and so I have the context of like, what is a hiring manager really looking for? I hired people who were PhDs, I hired people who had master's degrees, I hired people who were in their bachelor's program. I also hired like a 17-year-old kid, and he was one of the best engineers in the program. So, you know, my viewpoint is from training people, but it's also from having to hire people in the industry and like have them hit the ground running and design interview processes, you know? So I'm coming from a lot of different angles on this. So I'm here to answer any questions. If you just have any burning questions, you can definitely like drop them in Slack anytime. And I'll have some spaces during this presentation for that as well. Okay. So I just wanted to check to see if there's any of the other tutors or anyone else who wants to introduce themselves to everyone. I think Satya might be on.
Hi, yes, I'm here.
Hey.
Hello, everyone. I'm Satya Narayanan. I'm a faculty in the computer science program at CSU Monterey Bay. You probably saw me on the welcome message. We were doing something similar to this for our students for the last few years, and we had this opportunity to partner with CodePath and Chan Zuckerberg Initiative and Carrot to kind of scale this and serve more students. So it's very excited to see this group of faces, and really makes my day. So welcome all, and I hope you all find this interesting and helpful.
Any other tutors here, or anybody doing it?
Yeah, hey everyone, this is Utsab. I recognize many faces here, so happy to see you all continuing to you know, to improve and work on yourselves over the summer. And let's see, yeah, I in the previous summers I was leading some of the effort on the interview prep stuff, and I really like where Liz has taken this program this summer. So I'm happy to keep helping as a mentor. Come by my office hours and say hello.
Thanks, Utsab. Anyone else? Cool. Well, there's lots of tutors, more than just, you know, Utsab. There's a bunch of people who will help with this course. We've got a pretty large number of them, and you'll see if you've gotten the in office hours calendar, you'll see that there's a bunch of people out there trying to help. Okay, so let's just really briefly talk over kind of in detail, what are the goals for this class? The big thing is confidence during technical phone screens and interviews. So it's not just confidence in writing the code, right? I don't know, hands in the air in the participants window, just click on yes. If you've ever been through like a technical screen or like a technical interview before, who's done it? Let's see. Right. Cool. All right. So we've got a few people. Have done it. Now, how many people were really, really nervous when they did their very first one? Yeah, it's pretty much all the same people who had done one. Yeah, for sure. So yeah, I mean, that's a pretty common problem, right? Interviews are hard because it's not just writing code. It's also solving the problem and understanding, and also doing it in front of another person who is judging you, and that's really scary, okay? Like, everyone kind of gets nervous. I get nervous, right? Even though I do it in front of people on the internet. So it's a hard thing, you know? And the big thing about it is practicing and having had a little bit of context, and so you know, of like the programs and of the problems that tend to come up in interviews. Big thing is most questions are kind of similar, right? You might have noticed this by looking through the problems that are in Module 2, that there's some similarities between them. Even though they're asking you to do totally different things, there's a lot of similar aspects of each question. So we found that if we can just show you a lot of the most common patterns that tend to come up in interviews, we're pretty well prepared. And then as long as you can walk through a pretty well understood problem solving process, then you'll be pretty fine in interviews. You can figure out most things, or at least get really close to the end. Practice, though, that's what really helps you learn patterns, right? If we just showed you one question of each pattern, you would not really be able to have that like cross-cutting kind of view of oh, all these problems are pretty much the same type of loop thing, or oh, these problems all involve using a modulo, right? And so what we're really trying to do is get everyone together this summer and have them practice every day if possible, but as much as you possibly can. We know some of you have jobs or, side gigs or internships, so it's okay. But the more practice you can do, the more patterns you're going to be able to identify during an interview. And so that's really the big point of this. It's not just that, it's also everyone doing it together, because there's a certain amount of accountability that you can't really get alone. You could definitely just jump into Caddis or InterviewBit and practice. And if you want to do that, if you want to try other problems, that's super great. And we definitely want you to do that. The main thing is marching through it together so that we all stay on target, right? Because if you kind of fall behind, it's very easy to fall off the wagon and tell yourself, well, I'll catch up. I'm going to catch up maybe tomorrow, and then you never really catch up. You know how it is, especially in the summer when it's really nice out. Practice also helps a lot with nerves. If you just say things beforehand, like before this class, I went and said my introduction to myself a couple of times, and that helped me calm down before I went and did my very first Zoom teaching thing. Just so everyone knows, it's sort of my first Zoom presentation, so if I'm a little weird or awkward, that's kind of what it is. And what helped me, is really just practicing. And I practiced on a camera, and I imagined myself in those situations. And it worked, I wasn't super freaked out the time I came out here. So we're trying to give you opportunities to do that. But it's really hard, again, to do that alone. It's a little bit like writing something that is supposed to teach somebody something, like you don't know until you've put it in front of someone and they can kind of show you the holes. So that's what we're trying to get you to do. The end goal is that you just blow away an interviewer and land something that you want. That's what we're here for, is to get you into some technical program for which there's an interview, and then you just ace it. So that's the goal. So just to kind of reiterate on practice, daily practice is better than weekly practice. If you try to batch everything, like on Fridays when you don't have a lot of time, like you can do it that way. And if you're having to just work everything into your schedule, I want to stress, that's totally fine, but daily practice is better. Most of these problems are only about an hour to an hour and a half long. So you shouldn't really, you shouldn't be having to block off 4 hours to do this. If you just sort of hit it in the morning, what I've found, I've taught a lot of classes, a lot of what we call like immersives or boot camps. And what I've found is if you do it in the morning, or like right when you're sitting down to do your thinking work for the day, that really helps you both get started and get a quick win. You'll feel confident that you can solve other problems when you just sit down and practice one problem. What's also better is group practice, better than practicing alone, because a lot of times you can sit down, look at the problem, and it's, you're like kind of not sure about it, and then like your phone rings, and then you're texting, and then it's gone. But if you're practicing with a group and everybody starts and ends right around the same time, you're gonna feel that pressure to finish. So a lot of these tactics are about habits, and habits are really going to be what gets you through this course, right? To make sure that you get the breadth of examples that we're trying to get for you. Also, scheduled practice is way better than waiting for the mood to strike. If you're thinking, okay, well, then I'll do it in the morning, like after I'm done with coffee. Well, when's the end of coffee, really? You know? So what I would say is put some time on your calendar, block it off, and say, this is the time when I'm going to be doing my exercises. Reach out to some other people in your class and try to do it all at the same time, so that, you know, when people start being done, you kind of have that feeling like, oh, I really need to finish this, right? And you know that, you know, maybe you've got some support at the end, or if you're totally stuck, there are some people who can kind of ask you questions, maybe give you a little hint to get you moving forward. Try to take a look at this, that kind of thing. So these things really help, and they'll really help you like make it through this course. So on our end, here's how we're going to help you make it through this course. We're going to have guided topic sessions. That's this. Tuesdays, 6 to 8 p.m. And then I'm going to basically just redo this thing Saturdays at 10. During these, you're going to have a chance to ask questions, and we're going to go over some of the like concepts that you need in order to solve these problems. We'll also walk through the Umpire problem solving process, so that you can kind of like practice that breakdown over and over. So, we also have office hours throughout the week. The tutors like UTSAB has office hours. So there's a number of people that have office hours. And so while you're practicing, jump into office hours. And if you've got a solution but you feel like it's not the optimum solution, or you feel like it's not quite right, you can also jump into office hours and get help kind of analyzing and understanding your problems, or looking at your code for ways to make it cleaner or better or easier for you to read. The other thing that's really important is these activity reflection forums. There's sort of two reasons why we need them. First, we need to know that you are practicing, right? And we need to know kind of what's your process, how much time are you actually getting to devote to this? And then, you know, if you can't devote the time, like, we're trying to design a course that's accessible to everyone, no matter what situation they're in. So helping, you know, us understand what's going on with you, that's what these are for. But the other thing they're for is metacognition, which I'm an education nerd, and that's the term, is metacognition. What it really just means is thinking about thinking. And honestly, just reflecting back on your week and saying, did I do that practice? Did I spend the time that I was supposed to spend? If not, why? What rationalizations did I make? Or what got in my way, and what can I change? I told myself I was going to do it in the morning, but it turns out I'm a zombie in the morning and I just can't. But I'm really great at 6 p.m., so, you know, do them at 6 p.m. It's totally fine to put, you know, I spent 0 minutes in there, but we do need you to complete these reflection forms so that we understand what's going on. And that's going to be Tuesdays and Saturdays that you're going to complete those forms. All right. On Slack, there's tutors, there's volunteers, and there's your classmates, right? So if you're stuck, you're not sure, I've already seen a few people be like, hey, this question, it was weird, and it was weird. So, you know, just drop into Slack and say, hey, you know, I have questions, or I'm not sure what to do next. Totally cool. I'm also monitoring Slack, not like on it all the time, every single day, but I can jump in at different points and answer your questions or address any thoughts or concerns you have. Exercises are linked through Canvas. That's the stuff that we want you to practice, the specific problems that we're going to walk through. Either we're going to link to Replit, or we're going to link to these other platforms and tools, and I'll go over what's going on with those in a minute. The last thing, and these are going to be really, 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 really useful. I don't know if I said really enough times. Carrot.io is helping us out by providing some very realistic practice interviews. Carrot is a interviewing platform. What they do for companies is interviewing as a service. A lot of times at companies, engineers just don't have the time to like sit down and do a million interviews, especially for a lot of like junior candidates. And so Carrot does interviews for companies and then basically just passes them on to kind of the final round of interviews. So there's situations where you may actually, like if you're applying for a job, apply through Carrot and they may actually interview you. And that's kind of like literally their business model. And they're doing pretty good too. But what they're doing is they're volunteering to provide practice interviews. They're very realistic. They're going to be exactly like you getting an interview at a regular company because like they're trying to make it interviewing as a service, right? So we're going to do a midterm interview. So that's going to be, where you practice kind of everything you've done from the math module and the next 2 modules. And then we're going to do a final, like, second round interview. And that'll be practicing the more advanced techniques that you've used. If, in the interview, if you kind of spin out and you just start, like, you're not sure what to do, the Carrot people they're mentors as well. And many of them are actually helping tutor in the course. So they're going to just jump in and save you and help walk you through it if you get stuck. You want to try to make it as realistic as possible and pretend that like there's a job on the line though, because if you really super impress the Carrot people, they have connections, all of them. Like they're all in the Silicon Valley, like kind of Bay Area tech industry. And so, you're going to run into people who might be able to actually get you a job. And if you make a big dramatic transition and like improvement between your first interview and your second interview, that's what companies want to see. They don't care where you're at. They want to see your improvement. They want to see what the line is, right? So that's kind of the goal of these interviews, is to like help you project how brilliant you are to everyone. All right. Python is what we're using for this course. We're using it for a number of different reasons. Partly it's because it's a very terse syntax, but not as terse as like R or mathematical notation. It's easier to solve like interview problems in Python, I think, than stuff like C++, because it can take you sometimes like hours to solve a C++ problem because of the details and the data types and pointers and things like that. Python's a little bit simpler and a little bit faster, and it's a little bit more like writing pseudocode. So, and we've also found that it's easy to translate pseudocode to Python. So that's part of it. I've linked, and I'll drop my slides in the Slack, but I've linked to these different courses that we found for Python. I know many of you have learned, to code in like a C++ class. And so you're really just translating from one language to another. If this is your first, if this is your second language, I recommend like a longer course, maybe this 5-week or 13-hour course. But if this is like the 3rd or 4th language you've learned, just go for this 4-hour course and you'll feel pretty good at the end. That said, I'm also going to go over some of the basic Python tools that you might need. So if you need some help with Python, like, feel free to reach out, ask, and there'll be some coverage in these sessions. Okay, so let's talk a little bit. Let me just pause. Does anyone have any questions? If you do, type them in the chat. Pause for about 1 minute. Okay, doesn't look like there's a whole lot of questions. Okay, so let's move on to the Umpire Method. Just by show of hands, how many people have seen the very first video walkthrough of the Umpire Method? Go ahead and go to the Participants tab. I see a few people have joined in Zoom. And raise your hand if there's little buttons at the bottom. Raise your hand if you have seen that video. Okay, a lot of people have seen the video. Okay. All right, so that's good. All right, so there's a video of this if you haven't seen it. It's in Canvas and I'll show you where it is. So I'm gonna go over this, but not, you know, in crazy detail. So CodePath developed this process and I really like it. It's called the Umpire Method. And basically it's a way to break down a problem, and it's kind of I like it because it's an acronym, UMPIRE, so that, you know, when you're in the interview and you're like, oh, flustered, okay, there's a problem and I don't immediately recognize it or know what to do, you can just like stop, okay, go umpire. Remember that there's like steps you can take to solve the problem, even if it doesn't immediately come to you. You can calm yourself down for a second and then just go step by step by step. Being methodical in an interview and having a problem-solving process that you understand is really the most important thing to a lot of interviewers. A lot of people don't understand their problem-solving process. A lot of people they see a code problem and then just like at some point code starts appearing in their brain, or it just doesn't, you know, and it's like one or the other, right? And in an interview, when it doesn't start happening, you're just like, you don't know what to do. So this Umpire Method can save you from those moments. So let's talk about the Umpire Method. It starts with understanding. This is a big deal in startups, understanding what the person who is asking you to build some software is actually in a very detailed way asking for, right? And what an interviewer wants to see is that you're gonna read the spec that the product manager wrote in detail. You're gonna ask a bunch of questions and go, wait, but the data model, and you know, really detailed understanding is gonna come out of that, right? And sometimes it takes questions, sometimes it takes drawing pictures, sometimes it takes, you know, doing it by example a couple of times. These are really key steps, like in the understanding part, and it's the most important process to like show off in an interview. There's a lot of people who enter the industry and they kind of want to go in like with their own solutions, and interviews are designed to weed that out. So what they're really looking for is that, you know, you're going to be a team player and a good team collaborator. And so understanding it's partly a very hard technical skill, but it's also partly a soft skill, and why it's really important to understand and practice it, because, you know, there's a lot of details. And then matching. I kind of went over how most interview problems they kind of follow the same pattern, right? And so the goal of this course is to give you a bunch of problems to match against. So while you're doing this course, if you're given a problem and you look at it and you go, I don't have any matching for that, it's okay. We'll try to put some videos together for each problem where you won't have had any kind of matching experience, so that, you know, you'll kind of see it walked through, and then you can go through that process, and then you can look at the next problem and go, oh, how's that the same? That's basically what the match process is. But it's really important. Like without that process, again, I was a senior developer and like I wrote all this complicated, cool stuff, but I went into these interviews and I just hadn't seen these exact questions before, and I couldn't match, and that was where I failed, and that's after 10 years, so it's hard. The next phase I call plan, and so that's where we just write out the process. We go through the process that someone wants you to automate, right? Because that's most of the time what code is doing, is taking a process, breaking it down for a very, very simple-minded machine, and then telling that machine in very excruciating detail exactly how to do that process. And the way to do that is by telling yourself exactly how to do that process. There's a couple of videos where I do it for counting primes, and so you maybe have seen them there, but we'll go through the breakdown phase for a number of problems in every single module, so that you have a chance to kind of see what those types of algorithms look like as you draw them out. And then implement. Gosh, I just talked for like 5 whole minutes about all the things that come before coding. Well, it turns out there's actually a lot more that comes before coding. You know, I kind of feel like the sneeze, like coding is like the sneeze, right? It's like the sneeze at the end. You kind of have the like, and your body's like identifying you need to sneeze. And then right at the end, after you fully like, you sneeze and there's the code, right? And so that's like really what we're doing there is once you have a plan, you're just translating it. And it's like translating something from C++ to Python or from Java to Python, right? That's way easier than trying to remember Python and all of its syntax and constructs while you're making that. And then you want to walk through it. Now, when you're solving problems alone, walking through it just means testing it in your IDE. I recommend this tool called Python Tutor. I'll go over it in a couple of different videos. It's just pythontutor.com. It's pretty great unless you get an infinite loop. But it's basically to allow you to kind of walk through your solution and see how the different variables change as the code executes. It's pretty cool. I use it whenever I'm very confused about something and why something is happening. It helps me every day, so I love that. In a whiteboard situation, what they're gonna want you to do is walk through your code visually and be the Python interpreter. Try to find syntax errors or any logical errors where a variable doesn't increment properly or something like that. So that's a crucial phase, and they're gonna want that. And it kind of demonstrates your ability to look at other developers' code and help them spot errors, right? All code is a lot of details, and it's a lot to spot those errors. So it's kind of a soft skills thing as well, you know? So don't be hard on yourself while you're reviewing. Just say, oops, missed that, and that's kind of what they're looking for. The last phase is the evaluation phase. So a lot of people, when they're solving problems, try to solve problems by what's the optimum solution, thinking what is the most important, most fast solution, most efficient solution, or the least amount of code, etc. It's not important to do that on the first try. So you want to really by the end of the coding interview, you want to have a solution that works. And then you want to demonstrate that you understand your solution and what are the trade-offs that you've made. And at least come up with some areas where you might improve it, right? And talk over that kind of stuff. It's nice if you can, and if you have time at the end of the interview or the problem set to analyze and really make it more efficient, that's super great. But just being able to describe how your algorithm actually behaves at this point is really all we're looking for, and it's all anyone can really expect, when you're new, right? Being an engineer. Okay, so just wanted to ask if anyone, I just talked for a few minutes. Does anyone have any questions? Just want to look in the chat. If you do, I can jump in and address them. Not seeing anything. So let's see. Let's talk about what we're going to cover for this course. This is basically, again, support for the match phase, right? So the first week we're doing math. That's this week. Next week we're going to go into string manipulation and list manipulation. So we'll be, taking strings and lists sequences basically and kind of going over them, talking about the class of problems that those represent. That next week, we're going to really dive more into big O notation. We're going to talk about big O notation throughout. And so it's going to be kind of overlaid onto everything, but we'll take a few, the third week, the guided topic sessions are going to be about analyzing the algorithms that we have seen so far. So we're going to dive in, look at them, and go into the analysis of them and look at, how do we predict how our algorithm is going to grow over time. What if it had to handle more data, that kind of stuff. Week 4, we're going to go into like list manipulation in a deeper way, stuff like sorting and searching. There's a number of just algorithms you should know, stuff like quicksort or merge sort or insertion sort. You may have heard of these before. So we're going to just look at some sorts and some manipulation, list manipulation. Let's see, stacks and queues, linked lists, hash maps, and bit manipulation. That's kind of what we're covering the next few weeks. These are the most common interview questions that you'll get, especially if you're applying for any kind of like junior engineer or internship role, right? Most questions center on these topics. There are some stretch topics that I'm going to try to put in. It's largely going to be about whether or not we get there, or if everyone completes the course by the end. So I'm just going to try to get these in. There'll at least be some videos, and we will have some things for you to practice. But if nobody gets done by like the end of sort of course support, they might not have some guided topic sessions on that. Any questions on the course outline? Okay. Victor was asking about practicing, and should you practice with LeetCode or InterviewBit or Caddis or what, really? And the answer is yes. You should practice on as many problems as you can. The more that you practice on, the more you're going to be able to match. Okay, so I want to talk about Canvas for a moment. Let's see, is it this way? It's this way. All right. Can everyone see Canvas? Somebody just say yes in the chat for me. Cool. Okay. All right. So I want to just go over Canvas and how it works. If you've never used Canvas before, it can be kind of confusing. So as long as you have signed up for CTI IPS 2019, you should be able to see it in your courses list, right? It could be called interview problem solving. If you click on that, you should get to the modules page. The modules page is the best page to look at when you're thinking about, okay, what do I need to do next, right? The first module, it kind of talks about what are we doing here? How does the course work? What's the pacing? And how do the tools work? I've also added a Replit troubleshooting page here. So if you have any problems with Replit, go ahead and drop them in Slack. I'll try to troubleshoot and I'll leave some steps on this troubleshooting page. We found like 1 or 2 errors, and there's a couple of steps that you can take to fix them. So yeah, just in case you need any help. And at the end of every module, there's a module completion reflection. Go ahead and when you're done, please fill this form out, and it will help us to see that you're, basically what you are learning, and help us to kind of, tweak or orient or reach out if you need help. The first module is about the problem-solving process. I've got a bunch of different videos in here, and so if you kind of look in any of these particular pages, you'll see that there's a video embedded. And you can just click next to kind of get to the next phase of the module, right? So there's just a bunch of pages here. And then there are also some quizzes. The quizzes are not like a grade or anything. What the quizzes are designed to help you do is test whether or not you're understanding. So they're there to give you some instant feedback on am I analyzing the prompt correctly, or what are the steps to solving the FizzBuzz algorithm? So that's kind of the goal of the quizzes. They're really understanding tools, and that's why we've tried to mark them all as practice quizzes. None of them are like tests, right? The test is the interview, and if you pass the interview, you pass the test, and yay. But again, we're not like taking grades. It's not going into your GPA or So the first, like, I like to say, like the first like assignments module, the first one that has work in it is the math module. And so you'll see like what we're gonna do is we'll have 3 practice problems, and we've got this introductory problem, but 3 practice problems per module, so that, you know, we'll practice breaking them down and going through them. And then there'll be these assessments. Now, you don't get help with these assessments. They're really just for you to be able to check, can you do these things, right? Or can you do them on your own? So that's why we haven't made any like accompanying materials with the assessments. That's also what helps us to know that you can do it on your own. So please don't share your code for any of these assessments. There's, you know, it's like spoilers, right? And then there's stretch problems. So that's where you can, you know, keep up your daily practice. The stretch problems are a little tiny bit harder than the practice problems, right? And so I've embedded them here in Replit, which is one of the platforms that we're using. For me, it says student preview, but for you, it shouldn't say student preview. And so if you want to do them here, cool. If you want to open them up in Replit, you can just click right here, open in Replit, and then it will pop up a new window for you. So yeah, I've embedded them here, and then I've also made a link to them on their original platforms. I'll explain why we're having you submit on 2 platforms in a minute. Okay, let's see. The other thing is I've tried to add this Python syntax for module 2. I'll try to add basically like a list of tools that you need for each module. So there's a couple of videos for each one of these things that you might need: if statements, Boolean logic, or loops, range, modulo. And it's just got a bunch of good examples that kind of go over what these things are, how they help. They're just a bunch of different random YouTube videos. I watched them to make sure they were pretty okay. But they're a bunch of different random like channels. I wanted to provide just a lot of area for you to explore. So if you like any of these particular, you know, courses, you can dig in. Okay, last, and then yeah, once you're done, complete the module completion reflection, and then we'll know how it went for you. Cool. Let's see, we've got some questions, so I'm going to take a look. Let's see, every module has a completion reflection in it, just to talk about, you know, how is that module for you. It helps us with feedback. We can then tweak things if we need to, but also it, you know, helps us know that you're done with that one and you got all the way through it, so we can see, you know, are people dropping off. So the weekly so there's module completion reflection, and then there's activity reflection. Activity is about how much time are you spending, what's your discipline, what's your habits. Module completion is I'm done with the module. It's related to the content. It might be a little confusing, but it's mostly about communicating with us and not having to, you know, just like slack your answers and things like that. Does this mean we will be submitting a reflection twice for the same module? Oh, yeah, so, okay. Seems like Victoria got your question answered. And then, yeah, Frank noticed that for math problem 1, it is recommended to complete in REPL and in PBIT. And is it going to be standard? Yes, it's going to be standard. There's reasons, they're good reasons, I'll tell you. It's kind of a pain, but trust me, it's a good thing. Okay, so that's Canvas. Does anyone have any other questions on Canvas? Which RDE are we going to use for practice problems? So I like to use Replit, and I like to use Replit, and I'll kind of go over that in just a second. So, and then the interview bit problem was slightly different. Was that intended? Yes. We kind of, basically, we have a bunch of different problems kind of scattered across a bunch of different platforms, and we've moved them into one unified platform that makes it easier for you to share code with your instructors. You can click that you need help. And then it also makes it easier for us to kind of see like how many people are done. That, and not all of the platforms like have the friendliest IDE or user experience, and so Replit has a pretty unified, friendly user experience. But the other thing is we're allowed to give you more scaffolding code with Replit. But like with the other ones, like we don't have the ability to like change those things. So yeah, on the exercises, I just kind of wanted to say like, it's not about watching the videos, it is about doing them, right? Like if you took this, you wanted to do this ropes course and you were getting ready to do this ropes course, which would be more effective? Doing a ropes course or like a smaller ropes course, or watching 10,000 hours of videos about ropes courses? It's going to be doing a smaller ropes course. That's the answer, right? So you could not watch enough videos to where you're going to be able to just jump onto this ropes course and be fine. Even if you watch, again, thousands and thousands of hours of videos, it's just not the same thing as doing the exercises yourself. So remember that these videos are walkthroughs, but they're not the content of the course. The content of the course is the practice. That's really what a course is. This image is of a course, right? And there are accompanying materials, but it is really about doing it. So Replit, if you haven't gotten the classroom invite, everything's on Replit here. I can kind of go over how it looks. So it's okay. So if you're signed into Replit, you'll go into where it says student, and then you'll see that you should be in this classroom, CTI IPS. And then you should be able to see all these assignments, right? They're named after kind of what it is you're doing. Now, the way that you go in and solve them, you have some scaffolding code here. And what you'll do is you'll actually just change kind of where it says like pass or like your code here. That's where you're going to type in your code. If you need help, there is like a, let's see, where is the button for it these days? I moved it the other day. Let's see. Well, there's a way that you can ask for help in here, and I can't. Has anyone done this most recently with the I need help button? Sorry, I'm in the teacher view too often. Lost it. Well, I can submit. So you can submit up here, and what it will do is it will run some test cases. And if you click on those test cases, it'll give you more information. It'll say, you know, it'll say, pretty much it'll say self-assertion equals, and it'll have called your code right here with a variable, or with a value, and it will be expecting a result. And it says assertion error, and it tells you what your code returned. And so this returned none. And it should have returned 6. So it's telling you that your code has failed. It should have been 6, but it was none. So that's how you read these tests. Sometimes it's kind of really scary to like see a bunch of text here and read this stuff, but it'll actually give you a lot of information here if you're trying to debug what's going on, right? There's a little bit of information, that'll give you a hint as to what's you know, maybe broken about your code. But yeah, you can read down here kind of what was passed in and what was expected. You can also, you can say submit anyway or keep trying, and then, you know, you can like ask for help. I do think that you can share this, but let's see. I'll make a little video to explain how that works once I find the button. The other thing that you can do is you can just write code in this little REPL editor. So if you need kind of a Python environment, you don't want to set one up locally, this is a good way to do that. And in a minute, I'll kind of show you some Python stuff in this place. So that's Replit. That's what helps us kind of know, again, what is it that you're doing and see your submissions. We can see what you submitted, and we can also give you some feedback. So that's what helps us. We can't necessarily see your submissions on every other platform. So why are we using these other platforms then? Everyone wants to know. I built the suspense. Okay, so it's really, so LeetCode, InterviewBit, Caddis, a lot of these platforms, you know, they maybe started out just kind of with the big idea that they wanted to help people prepare for interviews. But, you know, I was the CTO of a learning platform, and let me tell you, all of these people they all have a business model. And the point of these platforms, from their perspective, is to actually help companies and other institutions who are hiring find new and emerging talent. And so basically, about, I would say 6 or 8 years ago, the whole internet kind of used to say like, hey, your GitHub is your resume. And so if you've got code up there, you know, like that's what proves that you're a developer. But so many people don't work on open source software that, you know, kind of the industry caught up to that idea. And they started doing these coding interviews, right? But it's a lot, you know, it's difficult to find people. It's difficult to identify new people who are learning to code who have some talent, right? And so these, especially InterviewBit, and I think LeetCode as well. HackerRank is another one. Interviewing.io has some problems. Let's see, there's, I mean, Code Wars, there's dozens. And what they do is they make it easy for people who are hiring to find you because you've basically proven that you can do these things. So even though there's not like a grade to this course, there is the ability to gain some street cred, right? Because having profiles that have a lot of activity, a lot of solved problems, what it shows is that you have discipline. It shows that you're learning and you're trying. It shows that you're succeeding, because if you're passing the tests, you know, you're succeeding. And that may prompt people to reach out to you. And so it'll kind of help your natural inbound opportunities. So let's see. In terms of like practice, we wanted to give you the most practice ability on Replit so that all your solutions are hidden, because in the beginning, we're not going to go over the most efficient solution. But for LeetCode, InterviewBit, and Caddis, when you submit code, some of them you only get the one submission, or, you know, when you submit a second one, like it logs it, right? So we'd like to be able to put you through these platforms where you've already gotten the chance to wrestle with the problem and you're not wrestling with it on their platform. And you're able to kind of put that out there and prove to the world, hey, I figured out this problem myself, right? And so it's really a way for you to improve your personal brand, you know, because as a developer, it does matter. Your personal professional brand it's how recruiters find you, and it doesn't stop at the end of your resume. It's your GitHub, and it's, you know, your InterviewBit profile, and your LeetCode profile, your HackerRank profile. So if you can find the problems on InterviewBit, LeetCode, and Caddis, we've linked to them so that you can do that. That's the point. is basically giving you a chance to show the world all the work that you're doing. Because for a lot of courses, like you do code to learn things, but you also, like, you know, you just kind of get a number at the end. This course, you get code at the end that the world can see that proves that you know what you're doing. So that's why. There's a good reason, and that's why. It's really to help you seem more badass on the internet. Cool. Okay. So a way to think about the differences between the prompt I'm trying to make them the most similar in Replit as I can, but the way to think about the differences between the prompt, or like how it runs, is on different platforms, they have different constraints that they've placed on your code. They either want it to run in a certain amount of time, or they want it to run with a certain amount of memory, or they want it to output in a very specific way. And so those are stipulated on the platform, and that's why we've like retained the original links and everything. Think about it like, you know, in a company, what you'll do is you'll always have a development environment. That's where you're working on it by yourself, maybe showing it to like one person on the team. The staging environment, which is like where you kind of put it out there for like your whole team, your whole company to see. And then the production environment, the live site, right? And so if you think about Interview Bit, LeetCode, and all them as the live production version, you'll note that, yeah, production kind of has a little bit different of constraints. It's got to run in a little bit faster of time. And so there's a natural process to development where you go from kind of, all right, I've got a brute force solution, to like, all right, I've got a nice efficient solution, to, okay, I've got the solution I'm going to deploy to production. And so this is kind of practicing that experience as well. So I know it's like, I don't want to press a bunch of extra buttons after I've solved this problem. Think of it as the deploy process, or like submitting your code for review, right? It's going to be very similar to that once you land a job or an interview, or I mean an internship. So yeah, it's pretty authentic. Any questions on that? Frank, on the interview bit thing, I'm not super sure what you mean, so I can kind of break out like at the end and dig into it with you if you like. So yeah. In terms of better, it's really more the number of platforms that you have a consistent good presence on than the specific platform. There's no like best platform. It's just like some companies use LeetCode, some use Carrot, some use Interview Bit, some use Caddis. So it's kind of like having, like putting your resume up on multiple job sites, right? It's not that one job site is better than the other, it's that you've got more coverage. That helps. Any questions on that? I know there were a lot of like anxieties around that, so any questions? Looks like no. All right, feel free to ask questions, drop them in the chat. No, I'm here. Okay, so here's the most handy Python tools for this week. What I'm about to jump into is just covering Python. I'm not going to cover like everything in the world about Python. I'm going to cover these few things. So I'm going to jump into this URL. And actually, let me post that also on Slack. There we go. There we go. Cool. Okay, so I'm going to, just so that I have like a little playground to practice in. And sorry, also wanted to, oh, there we go, sorry. Okay, so I just want to keep this up so we can look at the list. So here's what we're going to cover. And it's if statements, for loops, the range function, modulo operator, and then other operators, the ord function, the char function, and then just function definition in general. Okay, keep getting my windows moved around. Okay, there we are. Cool. So the first topic is pretty basic in programming. We're just talking about an if statement. In Python, you just write if some condition, and then you can put code under here. All if statements are pretty much the same process. So if we say that some condition is true, then the statement will execute. Print it's true, right? But if it's not, an else is basically like it won't, you know, some condition is false, then the else statement will run. So it's false. So you can kind of see what happens here. If we run this, it runs it's true. And if we switch this up here to false, it'll execute it's false. So that's sort of, you know, just like breaking it into two. But what if you have, you know, more than one thing that you want to check, like, you know, a number, right? And you want to check to see if that number is greater than or equal to a set of different numbers. In Python, what you would do is say if a number is greater than, let's say, 100, then it's huge. But if you want to check multiple conditions, the way to do that is to say L if. So it's just mushed else and if together, right? So here's where we can put like a second condition. It's, you know, a number is larger than 10, and a number is smaller than 50. And print it's medium. Otherwise it's something, I don't know. There's a bunch of conditions, right? Could be larger than 100, or sorry, it could be, you know, negative number, right? Smaller than 10 or larger than 50, but also smaller than 100. Oh, I've got invalid syntax. Oh, I need a colon. So a couple of things to note about, got more, oh, I put a colon here. Okay. Note about the syntax are that basically with an if statement, it's if and then the conditional. So this will evaluate to true or false. Then you have to have a colon, and then you must indent. If I don't indent here, what I'll get is an error, indentation error. Because in Python, white space is meaningful. Rather than brackets, we have indentation. This is kind of a compound Boolean value, and so this here, a number greater than 10, is one of the parts, and then a number less than 50 is sort of the other part. And because I put an and there, they must both be true. I could put an or, and that would change the meaning, because either of these could evaluate to true, but both of them don't have to. So this could be false, or this could be false. And this would still evaluate to its median. And you can kind of see it would, you know, for this particular example, it's not. So, but if you change this to 51, right, it'll still say it's median, even though this is not true. Else is just the default case. So if I change the number to like, 501, it'll say it's huge, but let's say change it to 5. It'll say it's something because the number is less than 50. So if I want to get, sorry, it says it's medium because the number is less than 50. So if I want to get it to say it's something, it has to be an and, because both of these kind of create a range that, like, it has to fall within. Okay, so that's if statements. Let's see, for loops. Let's talk about for loops. You may have seen for loops if you've watched some of the videos, but for loops are a pretty fundamental concept in Python. There's two different kinds of loops, for and while. For loops are basically like, in advance how far you want to loop. And they're really, really handy for looping over a sequence of things, like a string or a list. If you haven't played with strings or lists yet, that's okay. You will have played a little bit with them with the range function once you've done something. So I'll go over that. Okay, so for, let's say, I in, and I'm just going to use the range function, range to 10. I can print I. And all this is really going to do is print 10, the numbers from 0 to 9. So the way that Python works is for loops operate largely on like a sequence or a group of things, right? You say for and you declare a variable. I is pretty standard, but I like to write variables out. This is the iterator, right? And so then we can print iterator. And so this variable will become the value of whatever iteration of the sequence it's on. In order to really understand what's going on here, though, you kind of need to know like what's up with this range function. So I'm going to go ahead and just print range of 10 so that you can see what comes out of range of 10. So it'll happen after it says it's something and before this. Well, it just says range 0 to 10. Let's see. So basically range is a list. I guess it points out range 0 to 10, but yeah, you can convert it to a list by just pretty much doing this. And so this is kind of really what you're doing. You have this sequence of numbers that you've generated with this function. If you look at it in like Python Tutor, a range will get shown as a list. So yeah, essentially you're creating each one of these numbers, and that's what allows you to get kind of, each one of these values. But what's important is that you know that it's not the position, which is how it is in a lot of languages, especially if you've done C++ or JavaScript. You've probably seen something like for I equals 0, I less than the length of the list, I plus plus, right? And what that's doing is basically manually iterating. It's basically just a while loop that kind of is all defined on the line. But in Python, it's different. In Python, you're actually iterating over this range. So there's a couple of different arguments that you can pass in. I can, for instance, start my range at 1. If I run that, you'll see this range starts at 1, while this range is only 10. And so you can kind of see like starting from 1 to 9. But you can see also that like it stops at 9. It's not give me 10 numbers, it's stop at the number 10. So if I want to get the numbers from 1 to 10, I have to actually say the range of 1 to 11. Now I have the range 1 to 10. Something else that you may note about range is, let's say that I had 1 to 100 by 5. There's a third argument which allows us to count by a certain number, the increment value. So if we look at this, what we're doing is we're adding 5 to each number in order to get up to 100. So it's up to and up to, but not including the value in the middle. So it's get me all the numbers at this point between 1 and 100, counting by 5s, or adding by 5s. Not counting by 5s. You may have noticed, like, if I started at 0, I get all the 5s. But starting at 1, it just counts up by 5. So that's for loops. Y'all can just, if you want to see something or if you have any detailed questions while you're watching this, go ahead and just drop them in the chat. It'll help me to, speed up or slow down or, go over something that you might need to see. Okay, so the next thing we're going to cover is the modulo operator. So what I'm going to do here, rather than printing the iterator, I'm going to use the modulo operator. What the modulo operator does is you can kind of think of it as, I like to think of it as like a clock, but it's hard to make that thing like without a visualization. Basically, think of it as not like division, it's like calculating the remainder. So it's not how many times can a number go into another number. It's kind of like, see how like 96, it stops just before 100, because there's 4 like left over here. So if you were to divide a number by another number and then like it couldn't get in one more time to that number without some remainder happening, that remainder is what the modulo will return. So I'm just gonna basically print out all the numbers from 1 to 11, and I'm gonna tell you whether or not they're even or odd. So if iterator, I'm just gonna copy. Okay, cool. If iterator modulo 2 is 0, so that what that means is iterator, like 2 goes into iterator an even number of times. There's no remainder. So if that happens, I don't need these parentheses, I just write in JavaScript sometimes. If iterator, let's see, print iterator modulo 2 means that it's even, so it's even, and then else it's odd. And something that might help you while you're debugging is, I don't know if you know, but you can actually put commas in here. There we go. So I'll print out the number and whether or not it's even or not. Okay, so if we look at our output, 2 divided by 2 has no remainder. 2 divided by 4 has no remainder. 4 divided by 2 has no remainder. 6 divided by 2 has no remainder. But 7 has a remainder of 1. If we change that to 3, it's divisible by 3. It's not divisible by 3. We run that, and it'll tell us which ones are divisible by 3. Looks like it's 3, 6, and 9 under 10. So that's how we can use the modulo operator to figure out whether or not something's divisible by another number. You'll see this pattern a lot. Like if number modulo another number is 0, it's divisible by that number. So yeah, that's the modulo operator. You will use this in a bunch of different problems in this module. Okay, there's a number of other operators. So I'm just going to say, regardless, print iterator plus 1. And all that will do is print like the next number. And then down at 10, it'll be 11. There's other operations, obviously, that I can do. And they'll print, the last number. The slash is divide in Python. So, dividing it by 1. Any division turns a integer into a float, basically. So, you can get floating numbers out of the divider. There's also this operator here, the 2 stars. 1 star is multiplying it by 5. But 2 stars is raising it to the power of 5. That makes sense. So basically, this is how we get exponents. 5 is the exponent, and this is the operand. Any questions so far on operators? Okay, the ordinal function and the character function. You're going to need this in the Excel columns problem, but you're also going to need this in a bunch of the string problems, or anytime you're going to deal with translating numbers and letters. So basically the idea is that every letter in a string, this is a string here, is actually this letter, the letter I, or the character apostrophe, or the character space. Every single one of these has a corresponding ASCII value. So if you print the ordinal value, that's basically, if you think about what's the ordinal value, well, it's the order value, right? 1 is the first number, 2 is the second number, so second is ordinal, right? So if we want to know what the ordinal value of apostrophe is, down here we'll get it. It's 39. So I'm just going to say the ordinal value is, put a comma there. Cool. If we change that to lowercase a, you'll know we get 97. Uppercase A is different. It's 65. So every character, uppercase, lowercase, all the punctuation, spaces, literally anything that you can type on your keyboard, including if you use another language with a different character set, they all have an ordinal value. And it's stable across Python implementations because it all uses the ASCII table. So you're not going to run into like one environment where the ordinal value is 64 and one where it's 37. It's always going to be the same number. The kind of opposite of this is the CHR function. The character value is, and what you don't pass a string into it, you pass a number. So it's how to get that same number out, right? 65 is B, I think. No, it's A. Just saw that. Basically, yeah, let's just make this second thing. And so this tells us that the ordinal value of A is 65 and the character value is A. So you can kind of think of these things as the same thing, right? Anytime that you're using these two functions, you're really just translating between data because the computer thinks it's all numbers anyway. All right, so that's Python. Let's see, is there anything else? Oh, function definition. So the last thing is you may have seen this. We've provided it in scaffolding code, but basically a function is a great way to label the small problem that you're trying to solve. What I'm doing here is getting, the ordinal and character value of everything, or the same thing. So I just say def. What is the ord and char value? I like to make function names that are crazy long and really easy to like understand. I like to name them like this. And a lot of Python developers use the underscores, but I forget sometimes and use camel case. This is a function. You just have to say def in front of it, and that's kind of what makes it a function. You give it a name, like it's a variable, and then you can use it anywhere else in the program. In here, this is where you put a input value. This is the this is the argument. So you put anything in here like a character, and then I can pass that in here. You know, and then I could just make a quick little function to like, you know, character equals, and that way I can, you know, call this function on any character, and that way I can get the answer in kind of a repeatable way. So that's what we're kind of expecting you to do. Whenever you need to break a problem down into small pieces, you should write another function for it. And we won't have always given you that information, you know, for every single problem. Some of them will have pre-done it for you, but in this one, or in a lot of them, you may want to break a problem down. Okay. Any questions? I'm not seeing any questions. Is everyone asleep? Things. Cool. All right. So I wanted to do an exercise together and use the Umpire Method. I think we're only going to really have time for one at this point. So what we're going to do is last factorial digit. So what I want to do is I want to use the Umpire process to solve this problem, which means, okay, what I need to do is analyze the product, understand first. So I want to ask myself, okay, what is the key action that I need to do? Well, I need to return the last digit of the factorial of n. Okay, so I'm returning something. What am I returning? The last digit of what? The factorial of n. Okay, so I need to find the factorial of n, and then I need to return the last digit of that. Okay, what are my inputs? A non-negative number. Okay, and then so my output is the last digit of the factorial n. Great, so I've got my input. I'm getting a non-negative number. I need to find the last digit of the factorial, and then I'll output that last digit. So find the factorial of n, get the last digit, output that. Okay, so that's the understanding phase. Now the match phase. Have I seen a problem like this before? Well, in counting primes, I know I had to loop over every number to do something. And that's kind of similar here. So I can match against that first counting primes problem to go, okay, the factorial is kind of similar, right? In that I have to do the same thing over and over and over again a bunch of times. Anytime I see something that's like the same thing over and over again, I know I'm going to kind of be using a loop. I'm dealing with numbers and I'm maybe testing those numbers, so it kind of reminds me of that primes problem. All right, so like in my brain, I know that there's like an approach that's probably somewhat similar. So now I need to make a plan for how am I going to actually get the factorial and, you know, implement that. So what I like to do whenever I'm doing that is, and especially like, you know, you're live coding with your interviewer, just type out the sentences. So let's see, how do I actually get the factorial? And then how do I actually get the last digit? Let's focus on this first one, get the factorial. Okay, so in order to get the factorial of 3, given 3, It's 1 times 2 times 3. Okay, 6, it's 1 times 2 times 3 times 4 times 5 times 6. Cool. If I'd never seen factorial before and that was just a totally new concept to me, you know, this breakdown would be super, super helpful. And that's kind of what, like, imagine that you're in a, you know, whenever you're solving these things and you've seen factorial before, imagine you're in a situation where you haven't seen factorial before. Or you haven't seen like some kind of mathematical like process before. Sometimes you'll get in that situation and you can work it out by figuring out, okay, what's the process? And you can ask your interviewer, cool, tell me what the process for getting that information is. Okay, so I know that what I have to do is I have to go to each number up to the top, up to the input, right? So for every number up to the input value. And then what am I doing? I'm multiplying it against, I think, like the total that I've multiplied it against before. Because 1 times 2 times 3 is 1 times 2, which is 2 times 3. So it's really 2 times 3. So it's all of this times this. That's like, you know, the PEMDAS, like, please excuse my dear Aunt Sally. We go, you know, right to that. So, okay, so what I'm gonna do is, let's see, given an input value, save a total. Sometimes I like to note, like, what variables am I gonna need? Okay, so for every number up to the input value, multiply that number by the total. Okay, and so that'll give me the factorial of a number. Now, how do I get the last digit of a number and not return anything larger than that? That's kind of like, I'm just brute forcing this, right? I just want to put out this exact process into my function rather than try to think about like how, you know, efficient could it be. So how do I get just this one place value? Well, I will show you a trick that you can match on, which is that you can basically divide by the modulo, get modulo of 10, and it'll just wipe out everything over the tens place and just give you that last digit. So return the last digit. That's what we're really doing. So what I'm going to do is just copy this into my function. And then I'm going to put it on all the right indentation. And then I'm just going to translate to Python. So given an input value, that's n. We've already got that. Save a total. Okay, so total is 0. Cool. Now, for every number up to the input value, well, for let's say number, and I'll call it num. There's num the built-in. Let's see, current number. I like to use current number whenever I'm like iterating over a lot of numbers. All right, up to the input value. So how do we, in Python before, do that? Well, we did it with a range. So up to, that's really in range n. So up to, now it says up to, it doesn't say up to but and including, and it doesn't say up to and not including. So I need to kind of look at my process here and go, okay, if 6 is that factorial, it looks like we are multiplying by a 6 at the end. And so the thing that we noticed about the range function before is that we need to add 1 to it if we want to go up all the way, right? We also know that we want to start at 1. We don't want to start at 0. We don't need to multiply anything by 0, so I'm just not gonna. Okay, so that'll give us that. Now, what we need to do is multiply that number by the total. So I'm actually going to set the total at 1. And then I'm just going to say current number times total. Total equals that. So now I've multiplied and added to the total. And then I need to return the last digit. I just kind of talked a little bit about, you know, my pro tips on how to do that. The most brute force easy way, and that's like modulo total. So that just says, you know, however many times 10 can divide in, we don't care. But what's the remainder? Well, everything under 10. That's the last digit. Cool. So I've got my pseudocode. Maybe I want to save this. Shows like that nice maybe shortcut shot. And so I can run that. And now let's see, it's complaining. Okay, we got some invalid syntax. Cool. Don't have any more invalid syntax. So now, if you're testing, you can kind of call some things, but if you just run the tests, you click that down arrow and click run tests, it'll tell you, you know, that it's passing all the tests. Okay, so what phase of the plan are we on, or the umpire process? Well, we're in the implement process, right? And so what we want to do now is review our code, right? So let's like walk through our code real fast. So we start at total. If the total is, let's say, you know, 3, right? What we'll do is current number will start at 1. And so it'll be 1 times 1. And so, you know, you get 1. Cool. Then we get to the second iteration of the loop. Current number becomes 2. All right. Total equals 2 times 1. Cool. That's correct. And then we move up to the top again. Current number becomes 3. And the total is current number 3 times 2. Great, and that's 6. Okay, and then that's how it's being returned. The remainder of 6 being divided into 10 is 6. So that's how we got our stuff right. But this requires us to find the factorial. And that, you know, if you've tried to submit this exact problem on InterviewBit, you may have noticed that this, like, you know, they're like, no, that's no good. It's too inefficient, right? Because, you know, kind of the point of this function is to get you just the last value without having to calculate it, right? So you can kind of look at these tables here, and you can kind of think about like what changes. Like, what are the numbers that we're going to get back, right? So we could actually just run this last factorial digit function like a bunch of times to kind of see if we see like a pattern, right? And maybe if we see a pattern, then we can, like, you know, like fix it or like make it more efficient. So I'm just going to run this for all the numbers. From 1 to 10. Sorry, I'll split keyboard, so it sounds weird. All right. Oops, that's not what I want. I just want to run. Okay, so let's. Oh, I didn't print. Let's see. This is like the review and evaluate function part. And in an interview, what you want to do is you want to show people that, like, you see that your solution like achieves the test's value, but you know that there's, like, you know, maybe a cheaper or faster way to do this. So if I get this, you'll notice that after 4, so let's see, 1, 2, 3, 4. So at this point, we get all zeros. And so by running our function and kind of using it to test these values, I got to see that there's like a pattern. After 5, we're not going to see values that are too much. We just keep seeing like zeros. So let me just, let's just go up to like, let's just go like, 20. Let's actually go like 11, 14, 18, and 22. So let's run that and see what we get. Okay, more zeros. So I know a shortcut we could take here. I've noticed that basically once we hit 5, we never run into a last digit that isn't a 0. And there's a reason for that, that we kind of go over in not this problem, but like a later stretch problem. And so I'm not going to explain how this exactly works or why. I want you to kind of dig in and try to find it yourself. But what I can do is, having noticed that, I can kind of do this. I can say if n is 7, 5, right? Find the factorial. And then I can say like last digit equals total divided by, or modulo 10. But if it's over 5, because last digit is going to be 0. I just know it. I don't want to calculate it. I don't want to. It's too much work. So last digit is 0. Run test. Test still worked. Looks like I solved it. And so that's that last step, right? You want to just kind of like make sure that once your brute force solution works, you can kind of look at the outputs and see, is there some magical way to kind of notice patterns in the data and just say, it looks like I'm seeing a pattern here and I might be able to put in a shortcut, right? And so this saves like a lot of seconds on your execution if you're calling out on numbers like 30 or 40, right? Numbers where it's going to cause like a buffer overflow in, an unsigned integer. So, yeah, so that's that. So we can kind of go back to this guided topic session. Does anyone have any questions? Does anyone have any questions about that before we move on? Would total minus 1 work like it does in C++? I don't know what you mean by that. Like, oh, indexing into the total? Joel is asking a question, would total minus 1 work like it does in C++? So the answer is, I don't know what you mean. Maybe. If you're talking about like indexing into the number, like converting it into a string and indexing into it or something, that's like, I mean, it's kind of the same as doing the modulo 10 thing. So it might work, but I'm not really sure because I'm not sure what you mean exactly. Okay. Any other questions? Is everyone asleep? So I talked for like an hour straight. Okay. So I'm going to talk a little bit about groups and how you should solve, like really get into practicing. So you are all on different campuses and I have no control over who you're around or like what your like faculty members are telling you to do. What I recommend is form groups of 4. Groups of 4 are pretty good. Like usually you don't have an entire group disappear on you and you'll have enough recurring chances to talk over the problems and practice different interview strategies. So just try forming groups of 4. And when you do that, talk to the faculty at your school. They're supposed to help you form groups. So you want to just chat with chat with your professor or whoever it is that's like kind of running this locally, unless your faculty does the matching for you, which I don't think anyone is doing. Pick a group where you can all practice at the same time. Try to get like 4 people go up together and have them kind of go over that process. One of you could play the role of the interviewer. Let me tell you, even just pretending that for a minute with your friend that you know will blow your mind and change how you approach interviews, because you'll kind of realize like what it is, right? If all the people in your group have finished an assignment, or like if there's 2 have and 2 haven't, other 2 are like needing help, jump right in and pretend to be interviewing and try to walk through the umpire process. It will just change how you experience everything. And then also create a calendar invite. Most engineers, most people in like the tech world, they live on Google Calendar. That's where their lives are. So just create a calendar invite and like invite everyone, but also get on the idea of like having a calendar and like living by your calendar. So it's how it is in the tech world. And hold each other accountable, like bug each other. Hey, did you do the thing? If you all finish together, it's going to be a lot easier because you can compare experiences and share information about like who's hiring and what was the process like, because that's a really big thing. It's, knowing what the process is at a certain company or a certain, internship. Maybe you didn't get that internship, but your friend can get it, and then like your friend didn't get that other internship, but you can get it, So that's the thing. I've seen it done. It really helps. So just like, form a group and like do it together. All right, tutoring office hours. So many people want to help with this project. Like senior engineers from across the tech industry hear about this project and they're like, what? I could just help somebody not have to deal with interviews? That sounds awesome. I would feel so good about myself. That's what they want. So like take advantage of them. Try to spread out. I think a lot of people picked Wednesday, but there's a bunch of different people who are available at different times. The other thing, just drop stuff in Slack and somebody will jump on it. The other thing is, if you're going to office hours, try to have done something that day already. So you have it in your brain, because it kind of leaks out of your brain as you sleep, right? And so you need to have something that you've struggled with recently if you want the office hours to be really helpful. Faculty is going to have support office hours, so just take a look, right? They like teaching, so that's why they're here. One of the skills that you really need to practice is just talking it out with someone who is more senior. I don't know if you've noticed this magical, like, a senior dev comes to look at your code and it like starts working when it wasn't working before and stuff like that, right? It's totally normal. It still happens to me. And, I'm always also showing up to people and like their code starts working. Just talking it out, you like model the more experienced person's brain and like the method of their steps. And it just helps you to think through it. It also helps you to kind of go slower and be more explicit about each problem solving step. So just practice that with the tutors. Like they can kind of go over your solution as though they're going through an interview with you. They know about interviews, they've gone through them. Yeah. And the other thing is like, all these people are on your side. Like, we want you to win, we want it. So we're here for you, and like, but practice, and we'll pretend to be like judging you, and then at the end we'll be like, no, you did great. So it's gonna be okay. That's what the tutor office hours are for. All right, last thing that we really need to make sure you all know, hopefully you're all still awake and alive and paying attention. The first mock interview should happen between July 1st and July 12th. There's a lot of you, so we have to schedule them, and it's gonna be kind of a process to get everyone scheduled during those days, but I think that we can do it. So get on with the like Luce, who's in the channel, LUS, and they'll help you get your mock interviews scheduled. You don't get to schedule your mock interviews till you're done with the first 3 module assessment. So it'll happen like late June anyway. But like those are going to be your first mock interview dates. Don't be scared. Basically, what we expect you to do is the first 3 practice problems, like submit something for the first 3 practice problems. That's what we mean by done. The module assessment helps you and like us to know, but it's not what we need like you to do. We just need you to be familiar with the 3 practice problems. The next mock interview will happen sometime before August 16th. We think it will start August 1st, but it might start a little later anyway. It's so far out, it's hard to, put on people's calendars. So that's about when it will happen. And then due to activity reflection forms. It's more about your time spent and your habits than what module you completed. So that's what those activity reflection forms are. They'll be posted on Tuesdays and Saturdays by the Slack bot. We'll just pop them out there. So if you stay signed into that Slack, maybe like on your phone, you're not gonna miss it. You'll get the thing on your phone and you go, oh, I forgot almost done. You can do it on your phone. So it should be okay. Just sign into the Slack, and we're giving a lot of notifications that way. The guided topic sessions will end in August. Sometime early August, but if you're all chomping at the bit for more content, they're gonna end in August though, and then you'll have done your 2 interviews and you'll be ready to try some out. I'll be really excited to hear how it goes. Carrot is the name of the company doing mock interviews. This is how cool their logo looks. And just thanks again to everybody who's volunteering to help with this. Sure, maybe they'll watch this video or something, but yeah, thanks again for Carrot. They're the best. This is the link to the activity reflection form, just in case you're like, oh, I don't remember where it is, but I remember she showed me on that slide, here it is. And then I'm gonna skip this exercise for now because we'll be here all night if I go through it again. The big thing, just want to talk about growth mindset. Don't just watch the videos and Google the solutions. Talk through it, right? What you're doing is you're practicing the umpire process. That's the thing you're doing. You're not learning Python to become a Python developer, right? You're learning Python because it's good for interviews. It's also useful if you want to be a Python developer, but yeah, that's what you're doing. If you're going over something again with somebody, just ask yourself what you can be getting from this, because there's something you can get from seeing the problem over and over again. I learned things doing the Excel column challenge, and so you can learn something from things you've seen before. The baseline agreements, and this is kind of from the Computing Talent Initiatives cohorts. Show up when you're expected to show up. If you're gonna make a office hours appointment, or if you're gonna ask somebody for offline help, show up for that, or communicate so that people aren't waiting for you, because we only have so much time in the day. Focus on learning, I haven't seen anyone make a lot of annoying jokes or post GIFs and memes in the channel, but we're at school. Be at school. Be super respectful of everyone, because we're all volunteers, and or most of us are volunteers, and so we're really just doing this because we want you to succeed. And if you can't do the activity reflection forms, we're not gonna kick you out of Canvas and the Slack channel and say you're banned, we're gone. We're just gonna stop bugging you. And stop worrying if you're gonna finish. We're just gonna say, oh, well, maybe it's bored or dropped off or whatever. And we're just gonna consider you to have not made it through to the end of the class. So, talk with us. If you gotta go on vacation for a week, it's the summer, we get it, it's cool, let us know. Reach out just so that we don't think that you've just vanished or that you didn't like what we were doing and you're bored of it, right? But if you do, drop out, we'll send you a letter and say, we think you dropped. Okay. That's how it'll go. Let's see. Sorry, I'm trying to see how long we've been. Yeah, we're almost at time. So what I want you to do is with your groups, I don't want you to do this right this second, but the first time you meet with your groups, I want you to go around and do kind of the most common interview question starter. Most people aren't prepared for this when they go to an interview, and it's like a 3 to 5 minute talk with your interviewer, and it's just tell me about yourself. What are you supposed to say there? Am I supposed to talk about like my dog, or like what am I supposed to talk about here? What you're supposed to talk about is what are you interested in? Why did you go into CS? You know, they want to know how you're going to fit on the team. So a little bit about your interests like that aren't programming. Maybe you like video games. Maybe you like music and you're interested in signal processing because you love music, or you want to build a game engine, you know. There's all kinds of things you can talk about there, but what you want to signal is like, I'm an engineer and I like to dig into problems and solve them, and it's fun for me. And also just talk about like how you got here and what experience you might have. A lot of times it's about framing stuff that you've done in the past as experience in the engineering world, right? It took me a long time to realize that my experience, like starting a startup with my dad and doing engineering freelancing, counts. And it definitely counts, but it took me like a long time to get there. So, you know, just think back, okay, did I participate in hackathons? Did I take coding classes? Did I TA at a thing? Did I teach my little brother to code? Like, what did I do? You know, that all counts. Anytime you were writing code, learning about engineering, digging into robots, whatever you were doing throughout your whole background, like think about those things. And then you're basically just pitching yourself. You're trying to fit in as many sentences that make you sound like a power nerd, you know, as you can. So in your first group, I want you to do that. And then just practice doing that with people that maybe you don't know super, super well, and try to impress them. And just doing that one time before you go into an interview, like, will change the way that you approach it. All right, any questions? Last question I had was recommending a good editor for Python on Windows, and that is PyCharm is super great. Also, I've gotten into VS Code lately, and I'm into it. Yeah, I used to use Atom, and now it's VS Code, so those are my recommendations. Next time, what we're going to do is arrays and lists, and just kind of play with those and index into them and do a lot of model problems there. We're going to talk about strategies for that kind of stuff. Evaluating, we're going to dig a little bit into evaluating code for runtime complexity. I'm not going to worry so much about space complexity right now. We'll deal with that like as we move on. And then, you know, on stretch problems, bring your stretch problems. If everybody has like a similar confusion or something they want to dig into, bring them and we'll check them out. Ooh. Well, I'll hang out here for the next few minutes. I'm here to answer questions. Y'all can unmute and ask me questions or just drop them in the chat. Otherwise, that's all I got. This is my first Zoom session teaching. Like, I've always done it in person, and I'm used to seeing people in front of me, and you know, so y'all were great. Thanks for being a nice first Zoom audience. Thanks. All right. Feel free to drop off your names. Okay. All right, you two are the last ones. I'm gonna assume you kind of bounced. It's cool.